All right, class, in this video, we want to begin introducing functions. And we're going to begin by starting with this, what I call a T-chart. And this T-chart is what we call a relation. It's a relation because it is a set of ordered pairs. Now, when you see this X and this Y, this X and this Y on this T-chart, I want you to come over here to the graph and think of my X-axis and my Y-axis, because that is exactly what they represent. This X represents a point on the X line. The Y represents a point on the Y-axis. But these numbers are ordered pairs, and so we could write them this way. We typically do not, but we could. We see -2 in the X and a -1 in the Y, 0 in the X, 1 in the Y, 1 in the X, and 2 in the Y, and so forth. And so that is a basic set of ordered pairs that are related to one another. Now, when we move to this T-chart and the next one, we want to move beyond we want to build on the idea of a relation and decide, is this a function or not? Now, a function is a specific type of relation that assigns exactly one output to each input. Let me say that again. A function is a specific type of relation that assigns exactly one output to each input. Let me show you what I mean. And so when we look at this one, we have X. Now, the X is the input and the Y is the output. Now, I think this will make more sense in future videos when we're creating tables and whatnot from these function tables. But for now, the X is what you put into the system. The Y is what you get out of it. And so if I put a 2 into whatever mathematical equation I'm going to write, which I'll give you examples later, when I do the math, multiplication or exponents, division, addition, subtraction, or a combination of all, the final result is a 1. And so when I put in a 2, I get a 1. When I put in a 4, I get a 3. When I put in a 5, I get a 4. And when I put in 9, I get a 7. Please don't worry about the rule or how I'm going from 2 to 1 or 4 to 3 or 5 to 4 or 9 to 7. Right now, I just want you to see the concept that each of those input values results in a distinct Y, a unique Y. That is a function. Now, it's often helpful to see, hey, when does it not work? So let's move to this example right here, where I have my input and my output, my X and my Y. And look what happens. When I insert a 2, I get a 1. But wait, here's a 2 here as well. So that same 2 also produces a 3. Now the 5 gives me a 4, and the 9 gives me a 7. All right, now this is a problem. This is not a function. Now why is it not a function? Because this 2 has to give you a distinct output. It cannot give you two different numbers. Let me try to illustrate it with a graph. Here I go to 2 in my X and 1 in my Y, 2 in my X and 3 in my Y. Now 5 would be over here, and I go up to 4, and then 9 and 7 is out here. Now look at these 2 points right here. These are the culprits. They are occupying the same vertical line. They are occupying that same vertical axis, if you will, and I can't write a rule for a function that's going to produce that. Okay, now here's an unrelated equation. Like you've seen these before in class. Y equals 2x plus 3. Now any value I plug in for x, let's say a 1, that's going to be this. My Y is going to give me 5. This would be my output. Here is your output, and the 1 is the input. That's what we're doing with these rules. We'll talk more about that later. But you see here, if I plug in a 1 again, I'm going to get a 5. I'm never going to get something else like 3. But that's exactly what's happening right here. There is some sort of rule that's existing that's producing different values, different outputs for the exact same input. And that is not a function. Let's look at some examples real quick. And so let's look at this first example right here. And I can see the 1 produces a 1, but look at that. The same 1 produces a -1. This is the same 1. I've just written it twice. And so the 4 goes to 2, the 9 goes to 3. That's great. Not a function. And again, why? Because the 1 gives me 2 different outputs. That won't work. In this other example, 2 gives me a 3, 4 results in a 5, 6 results in a 7, and 8 results in a 9. That is a function. Every x value gives me a distinct y value. Well, what about from a graph? Let's look at a graph here. Now, I mentioned a moment ago, I believe, something about the vertical line test. And this is basically, if I can drop a vertical line, and we'll pretend that's a very good vertical line, and it only crosses the graph in one spot, it's a function. It is, and this is a function. It's what we call passing the vertical line test. Now, this is really a linear function. This is a line. It can be written in the form of y equals mx plus b. It passes the vertical line test. It is a function. But look at this graph. When I draw a vertical line here, I cross this function, or excuse me, this graph in 2 different places. So example, if we mark this spot right there as 3, and we'll mark this spot as, say, -5, and up here we'll just say that's a +6, just making up numbers here. That means this coordinate is 3 and -5. This coordinate is 3 and 6. And I hope you can see how they have the same x value, but it produces different y values. And that's exactly what we were showing in the chart. So this example is not a function, because A, it fails the vertical line test, and B, if I want to show that numerically, I can assign it coordinate points and see that the x values are the same, but it produces different y values. Not a function. Let's look at this one. We've got a point here, 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 and here. But look at this. Hopefully my drawing shows up well. And I got a little off there, but those 2 points occupy the same point on the x-axis, right there. And it looks like 1, 2, is that 3? It's hard to see on my screen. And so because the x values, I don't even care what that y value is at this point. I just see that, wow, they're occupying the same point, the same x-axis, and I know these are different, okay? This looks like maybe 3 and -3. Again, the grid is pretty light on my screen. And so I see the same x, different y's, and that is not a function. All right, let's look at some examples real quick. This is a good time for you to stop the video and just run through these really quick to see if you get them correct. All right, so hopefully you did that. This is a function. Does it pass the vertical line test? Yes, it does. Can it be written in the form of y equals mx plus b? Yes, it can. Number 2, here's my vertical line. Look at that. It strikes it in 3 different places. Not a function. It fails the vertical line test. In this case, I'm going to have an input that gives me 3 different outputs. That's not going to work. And in this case, I have a point here, 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 and here, just 4 points. None of those share the same x coordinate, okay? And so we're going to call that a function. Hopefully this is a good introduction into functions, and we'll move on to the next video.